A. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh, yeah! Check out my new weapon. Piranha gun! Oh, yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. You doing a demonstration? Oh, shoot. It's so difficult sometimes to get the line back inside. Oh!
Hi, so you watched that short video about vector, and Unit 3 is all vectors, so I wanted to just kind of show you that video because he explains exactly what a vector is when the character Vector is talking about who he is when he introduces himself. So a vector, from that little clip, he says he has magnitude and direction. So that's exactly what a vector is. Okay, it has magnitude and direction. Okay, so for example, it could be 5 miles per hour east. So we have the 5 as our magnitude and the direction would be east. Okay, and this is what it looks like. So we have A, and then we call it vector U, but it goes from A to B. And just to note, this is not a ray. Okay, and it's usually denoted, so we'll use a bold letter, which that's hard to write, but it'll be bold. Sometimes we'll write it like we did a line segment, AB. Most of the time I'll write it with the little like half line at the top. So that half line means it's a vector. If it had like a full arrow, that would be a ray. So if I just have like half of the arrow, that would be a vector. We can also write it like this, but we'll typically use bold or put this little half arrow on the top. Okay, so we have position vectors, and that is our vector in standard position. So there's not a lot we can do unless our vector is in standard position, and that just means that it starts at the origin. Okay, so a position vector is a vector in standard position and the initial point is at the origin. Okay. So the two components of this vector are going to be A and B, right? So I go over A and up B, and that gets me my vector U. So just as an aside here, so if I wanted to figure out how long U would be, this is essentially a right triangle. I have 2 of the sides, so how could I figure out what that third side is? We can use Pythagorean theorem. So that would get me A squared plus B squared equals U squared. We're not using C here because we're in vectors. But I don't have any actual numbers to put in here. So we just need to think, how can I get rid of this squared? Well, I can take the square root. So the square root of A squared plus B squared is going to equal the length of my vector U. Okay, so the length, we can think of that as similar to the magnitude. So if I have a vector AB, okay, and this is like I went over A and up B, so it is kind of like an ordered pair, but we use pointy brackets, and the brackets do matter. So we'll use pointy brackets for a vector, and then if I do the magnitude, it's going to equal the square root of A squared plus b squared. Okay, and this right here is the magnitude, not absolute value. Okay, a lot of people get that confused. If a vector is inside of two lines, it's the magnitude. It is not the absolute value, and this is the formula for that. We're not going to worry about that formula. So I want to find the magnitude. So let's look at an example. Find the magnitude of vector u, which is 3 and -4. Okay, so I just set up my formula. So magnitude u equals the square root of 3 squared plus, and then I'm going to put that -4 in parentheses. Okay, there's a reason for that. Whenever you have a negative, you want to make sure you put it in parentheses, because if you type it in the calculator without the negative, it's going to square the 4 and then make it negative. But you want negative times a negative. So please make sure you are putting that number in parentheses. And then you can actually type that in the calculator all at once. So I want you guys to type that in the calculator to check your answer with mine. So square root of 3 squared plus, and then in parentheses the -4. Make sure the squared is outside of the parentheses. And we should be getting the square root of 25, which is 5. Okay, so the magnitude of this example is 5. Okay, so let's try one on our own. So u is -1, 5. Okay, so find the magnitude of that. So if we plug them in, the -1 goes in parentheses because it's a negative, and then -1 squared plus 5 squared equals the square root of 26, which gets me 5.099. Okay? So all of these vectors will have a direction. So if we, well, I have the picture down here. So this was my vector, but now this is going to be the direction. Okay? So I could have a vector that maybe goes over here, and then this whole thing would be my angle. Okay, this whole thing. So it's kind of like when we were graphing angles, and I would give you like graph 150 and state the reference angle and quadrant. That's kind of what we're doing here, but I'm going to give you the vector, and we now have to go backwards and find the actual angle measure. Okay, so just well, let's do the definition. So the direction angle is the positive angle between the positive x-axis, so this axis over here, and the position vector. Okay, so this right here is our angle for this particular example. So let's kind of go through and figure a little aside here for this one. So if this is my picture and this is the angle I want, when they give me the vector, they give me A and they give me B. So if we use SOHCAHTOA, okay, coming back to that, how is the A and the B related to this angle? Which trig function do I use? Well, I'll use tangent. So tangent of theta is going to equal B over A, okay? But if I'm solving for this angle, do you guys remember what we need to do to solve for an angle? What do I do to both sides? We'll take tan inverse. So here, these cancel out, leave me with theta, and this is going to be tan inverse of B over A. And that's our formula. Okay, so the formula will be theta, because that represents an angle, is tan inverse of B over A. There are some odd things that happen here. If theta is in quadrant 2 or 3, you have to add 180. If theta is in quadrant 4, you have to add 360, okay? If it's in quadrant run, we don't have to add anything, so it'd be 0, 180, 180, 360. Those you'll just have to memorize, and I can't really explain it to you right now because we don't understand what the graph of tangent looks like, but when we get to the graph of tangent, these numbers will make sense. But for now, if it's in 2 or 3, you add 180. If it's in 4, you add 360, okay? All right, so let's look at an example. So now we'll use vector v, and that's going to equal -1 and 5. Okay, so this first one is A and the second one is B. So we can graph that quick, and we graph it like an ordered pair, so -1, and then 1, 2, 3, 4, 5. So, and then it always goes from the origin. Okay, so that's kind of where that is. So I'm looking for this angle. Okay, and we know that this is +0, plus, I always like to write this in, plus 180, plus 180, plus 360. So right away we know we're going to have to add 180 because it's in quadrant 2. So then I just plug them into my formula. Tan inverse, and then I'm going to do B over A plus the 180. Okay, and if it's over here, we know it has to be between 90 and 180. So wherever you graph it to be, when you do tangent, you'll automatically know if you added the correct thing because over here it has to be between 90 and 180, otherwise my answer is wrong. So you type this in your calculator, so tan inverse 5 divided by -1 plus 180. Make sure you close the parenthesis after you do 5 divided by -1, and we get 101.31 degrees. So we know that 101 is between 90 and 180, so we're good. Okay, so this angle measure here is 101 degrees. Okay, so let's try one of those on our own. So 3 and -4. So try that one on your own, then we'll go over it together. Alright, so for this example, when we graph it, it puts me in quadrant 4, which means I have to add 360. So if I fill it in, tan inverse of B over A plus 360 is going to get me 306.87 degrees. Okay, and that should make sense because it should be between 270 and 360, and it is. Okay, so let's put these together, and sometimes I'm given vectors from, so all the vectors we've dealt with before started with the origin, so I just denote them with one number because I know that I'm starting from 0, 0, but sometimes we don't start from the origin, and let's say I start at 2, 4 and go to, so it's from 2, 4 to 7, -5. Okay, so I kind of have this graph here, so if we go 1, 2 and then up 1, 2, 3, 4, so that's where I'm starting, and then 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. Okay, so notice I'm not starting at the origin, so I need to make it start at the origin. So what I'm going to do is I'm going to take this whole line and I'm going to shift it down here. But mathematically what that looks like, so we'll convert to position vector. Notice when it's not a position vector, the brackets are, or the parentheses are just regular parentheses instead of pointed. Okay? When I convert it, we'll use the pointed, and I'm always going to take the second, like we'll take the x's, and we'll subtract second minus the first, and then I'll take the -5 and subtract the 4. Okay? So that ends up equaling 7 minus 2 is 5, and then -5 minus 4 is -9. Okay? So essentially what we did was I shifted it over 2, so I subtracted 2, that's how that works, and then I went down 4, so I subtracted 4. So this, I went over 2 and then down 1, 2, 3, 4. Okay, and then this is my new vector. So you can kind of see from the picture, that's why we subtract. So I subtract 2 to move it over here, subtract 4. Okay, so that's why we take the second one and subtract the first one. It puts me in this position. Okay, and then we can find the magnitude and the direction. So if I'm finding the magnitude, that's just my formula. So it's the square root of 5 squared plus negative 9 squared, which equals the square root of 106, which is 10.30. Okay, we type that in the calculator. And then the direction is going to be tangent inverse of B, which is negative 9 over A, which is 5. And then I'm in quadrant 4, so remember plus 0, plus 180, plus 180, plus 360. So I'm going to be adding 360 here. Type that in our calculator, and hopefully we get a number between 270 and 360, and we do. It's 299.06 degrees. Okay? So if they're not given, if you're given 2 and it's not in the position vector, you take the the second point and subtract the first point. Okay, so let's try one of those on our own. From 1, 4 to negative 3, negative 2. Okay, so again, if we graph those 1, 2, 3, 4, that's my starting point, and then negative 1, 2, 3, and then negative 1, 2. So there's your starting point. So see if you can find the magnitude and direction. Alright, so your position vector was negative 4, negative 6, because we subtract the second point from the first point. And then this is what the picture looks like. So, and if you wanted to too, if you know that I need to move over 1 and down 4, and you move this point over 1 and down 4, you can figure out what that point is, and that would be your position vector also. And then we do the magnitude, make sure you put them both in parentheses. We get 52. Square root of 52, which is 7.21. When we do the inverse tangent for the direction, we have to add 180 because we are in quadrant 3, which makes sense because between 180 and 270 is 236.31, so that number makes sense, so we know we added the correct amount. So the magnitude is 7.21, and the direction angle is 236.31. Okay? So make sure you guys are completing the homework assignment for this, and then please reach out if you guys have any questions.